The binomial CDF function can get a little bit tricky, but it's still a lot easier than doing these by hand. So going through an example of how we would use this, if we have a multiple choice quiz and you end up not studying and guessing on every single question, there are 5 questions, each with 4 answers and only one is correct. The probability of you getting one right, probability of it being correct, is going to be 0.25, since only one out of the 4 is right. So now what we're going to do is calculate the probability of getting exactly 3 correct. Now we're going to go to our calculator, and since it's exact, we're going to use the binomial PDF, P for precise, under our distribution function. So second vars, we're going to arrow to the binomial PDF function, and we're going to put in our n, p, and x values. Our n value will be 5 questions. So we have 5 for n, our p value 0.25, and our x value, we're trying to figure out probability of getting 3 correct, so 3 will be our x, and enter. So we only have the probability of 0.088, or an 8.8% chance of getting 3 correct. Now, the next one, probability of getting at least 3 correct. You got to watch these words because they can really trip you up. If you're talking at least 3 correct, that means that 3 would be okay. At least 3 would include 3, it would include 4, and it would include 5. The only ones it doesn't include is 2 or below. So since I have this function that does the binomial cumulative distribution, I'm going to go to second distribution, and I can actually use this cumulative function to figure out what this is merely by calculating it for 5 and below and then subtracting out 2 and below. Well, if you want to put in the cumulative for 5 and below, I'm going to put that in right now. If I accumulate, I'm going to use my same n, 5 questions, comma 0.25, comma 5, and you probably know this answer even before I get there. Notice that the probability is 1. If I add up every possibility for 5 and below, that is going to be a probability of 1. So what I'm going to do is I'm going to take that 1 minus the probability of 2, 1, and 0. So I'm going to do the probability involving 1 minus binomial CDF of my n value of 5, my probability of 0.25, and 2 and below. So 2 and below. And I can put this into my calculator just as I have it written here with, and I'm going to slide this up. I'm going to hit my 1 minus, I'm going to hit second distribution, arrow up until I get to my CDF function, hit enter, and then I'm going to put in 5, comma, 0.25, comma, 2. That probability is now at 10% or 0.1035. My next question says the probability of getting between 2 and 5 correct inclusive. The word inclusive means that we're going to have both the 2 and the 5 and anything in between included in. Now, I'm going to show you kind of the longer way because your problems on your homework might involve, having to do it this way. So I am going to give you the probability, binomial CDF. Since we're including 5, we'll have 5.25 and 5. So that would accumulate from 5 on down. And then we are going to subtract out the binomial CDF of 5.25. And notice that since it's including 2, I'm going to go down to 1 and get rid of 1 and 0. So instead of writing 2 here, because 2 is included, I'm going to write a 1. And that's how I'm going to put it into my calculator. So when it's inclusive, be careful on that one. All right, so I can put this in, going second distribution, binomial CDF, 5, 0.25, 5. And then I'm going to subtract second distribution, binomial CDF, 5, 0.25, 1. I can put it in as one big long equation and hit enter, and I end up with 36.7% or 0.367. And usually go out to 4 decimal places when you use the decimal format.